Hey everybody, and welcome to statistics lesson number 7, making inferences using samples. So we know what a sample is. It's a part of a population that we are able to survey, study, and look at because we can't look at the whole population. Now we want to look at making inferences using this sample. An inference is going to be a conclusion based on evidence and reasoning. So our evidence is going to be what we got from our sample, and we're going to use that to say something about the population. If we look at example 1, Stephen surveyed people from 7th grade to see what their favorite color is. He asked 20 students and 7 of them said red. If there are 320 7th graders, how many of them would you expect to pick red as their favorite color? Okay, so we want to compare the sample, which is going to be those 20 students, to the population, which is going to be the 320. How we're going to do this is setting up a proportion. If we know that 7 out of 20, so 7 out of the 20, picked red, and we want to see how many are going to pick red out of 320 students. So we set up our proportion. We're comparing the students that picked red to the total amount of students. Okay, now solving this proportion, we solve just like every other one. Cross multiply. So 20 times x, it's going to be 20x, and then 7 times 320. Okay, let's bring down the 20x. We multiply using the calculator, 7 times 320. We get 2,240. So 2,240. Now we have a one-step equation. 20x equals 2,240. Divide by 20 on both sides. Divide by 20. We get x on this side equals, divide that 2,240 by 20, and we get 112. Okay, so based on our survey and that sample, right, 20 students, 7 of them said red, we would expect 112 students to pick red out of the whole population. And that's our answer. Let's look at example 2. So a sunglasses company took a sample of 120 pairs of sunglasses to see how many were defective. Of the 120 pairs, 13 were defective. Based on the sample, how many pairs would they expect to be defective in their warehouse containing 22,400 pairs of sunglasses? Okay, so now we're not comparing red to total, we're comparing defective to total. So let's set up our proportion. Defective over total. Now the sample, 13 in the sample were defective out of 120. Now we want to look at the population. We don't know how many are defective, but we know that there's 22,400 total pairs of sunglasses. Okay, we want to cross multiply. 120 times x, which is 120x, equals 13. We're cross multiplying here. 13 times 22,400. So 120x equals 13 times 22,400 gives us 291,200. Okay, now we have a one step again. Divide by 120. Divide by 120. And we get x equals 2,426.6 repeating. Now, if we're seeing how many we would expect to be defective, if we have 0.6 repeating, right, we want to round that. We don't have 0.6 repeating of a sunglass pair that's defective, right? So let's round it up. It becomes 2,427 pairs of sunglasses. Okay, that's going to be our answer. All right, one more example. So here's example 3. If you want to try it on your own, hit pause. If not, we'll work through it together. A survey was done to see how many people have solar panels on their house in a neighborhood of 150 houses. In a sample of 20 houses, 3 had solar panels. Based on the sample, how many houses would you expect to have solar panels in the entire neighborhood? Okay, so now we're comparing solar panels, I'm just going to call it SP, to total. In the sample, there was 20 houses. 3 of them had solar, so 3 over 20. And the neighborhood, there's 150 houses. Not 150 houses with solar, 150 total. Put our x on top, and we cross multiply. Here we get 20x equals 3 times 150. 20x equals 450. Divide by 20. Divide by 20. We get x equals 450 divided by 20. It's going to give us 22.5. Again, this 0.5 doesn't really make sense here. We don't want to say, well, about 22 and a half houses have solar panels. That doesn't make sense. Half of a house has a solar panel. So we want to round it. 22.5 is going to round up to 23. So about 23 houses will have solar panels. Okay, so that's how we're going to make inferences using our sample. That's why we take samples, because we want to say something about the population. All right, see you guys later.